Hello class, welcome to chapter 9.1, add and subtract polynomials. So let's get started. So the first thing is a monomial and polynomials. So let's talk about monomials first. Monomial is, this is probably note card worthy again, a monomial is a number, a variable, or the product, okay, key term right there, or the product of a number and one or more variables with whole number exponents. So let's look at our little chart here. They're saying that 10 is a monomial, okay, but it has a degree of 0. We note that 3 times x, so or the product of a number and one or more variables, so 3 times x, but it is to a degree of 1. Here we have 1/2 times a times b squared. Well, we know that this has a power of 1 right here too, so what they do for a monomial to talk about it, the degree, they add those together, 1 plus 2, which equals 3. And then here at the bottom, negative 1.8m to the 5th power has a degree of 5. So things that are not monomials, okay, things that are not, I did not list this, but let's say that we had, 4 to the n power. That is not a monomial. Monomial must be a variable that has a whole number exponents. Okay, whole number exponents. So this is a variable exponent, so that would not count as a monomial. 2 to the negative 3rd. Okay, a whole number exponent. Positive whole number exponent. Okay, negative exponent does not work. Okay, x plus 5. Okay, this is not a monomial because it says product. It has to be multiplication, so that is not a monomial. Okay, so make sure you understand what a monomial is. So let's move on to polynomials. A polynomial is a monomial or sum of monomials, each called a term of the polynomial. Sorry. The degree of the polynomial is the greatest degree of its terms. So here we go. This is the key here. When a polynomial is written so that the exponents of a variable decrease from the left to right. So I'll give you an example here so you can see that their exponents decrease from left to right. We have a degree of 3, a degree of 2, a degree of 1 here. Okay, and the coefficient of the first term is called the leading coefficient. So the leading coefficient on this is 2. Okay, that's what I have this underlined right here. Leading coefficient is 2. The degree of this polynomial is 3. Okay, the degree of a polynomial is the largest degree that it has. And then the constant term is 12. Okay, this number that's at the end that has a degree of 0 on it is the constant term. Okay, so very important terminology there. May want to review that again, but we've got to understand that a polynomial is made up of a sum, okay, of monomials. So let's look at an example here. It says write 15x minus x cubed plus 3 so that the exponents decrease from left to right. So let's do that first. So the exponents decrease from left to right. So the highest degree we have exponent would be negative x cubed. It's very important to take this negative sign along with it because that is attached to that. So the next highest degree we have is 15x, which is a positive 15x. Okay, and our constant term, which will always go at the end, is 3. So identify the degree and the leading coefficient of the polynomial. So the LC, the leading coefficient, okay, is the number that occurs in the highest degree. So from left to right, that'll be your leading number there, which is a negative 1. And then the degree of this, okay, is the leading number here is a 3. We have a degree of 3 here. Okay, and if you forgot any of those terms and how I did that, you just look back here, okay, at this key piece right here. Okay? Alright, so let's look at adding polynomials. When we talk about adding polynomials, we have to think about like terms. Okay, adding or subtracting, we have to think about like terms. So what I always want to make sure is that we first look at what's inside our parentheses and is it in the correct polynomial form. So we have a degree of 3 here, a degree of 2, and a degree of 1. So this is correct from left to right. Here we have 2x squared plus x cubed minus 1. Okay, that is not written in correct polynomial form. So what we do is this, and I like to do this vertically. And what I mean by that, I'll show you in 1 second. I'll rewrite the first one. Now I like to do it vertically up and down here. So plus x cubed has to go first, and we can put a leading coefficient on that one as 1. And then positive 2x squared. Now here is my negative 1, and they have x. These are not like terms, so I have to put the minus 1 down here. So I almost am creating columns here, okay, with the like terms. Okay, very important that you combine like terms. So here, 3 or 2x cubed plus 1x cubed is 3x cubed. Okay, remember this exponent, this degree of 3 here does not change, because in last chapter you learned the exponent only changes when we multiply them. So we're not multiplying, we are adding here. So that degree stays. So negative 5x squared plus 2x squared is a negative 3x squared. This x just gets moved down, and this negative 1 gets moved down. So my polynomial here is 3x cubed minus 3x squared plus x minus 1. Okay, and at the end, make sure that that is written in correct polynomial form from left to right. The leading coefficient on here is 3, and the degree is 3 as well. The constant term is negative 1. Okay, so again, step 1, make sure that each polynomial inside of its parentheses is in correct polynomial form from left to right, and then create it vertically. Okay, another thing that they'll do, some people like to do it horizontal, is they'll put 2x cubed plus 1x cubed, and they'll put the like terms inside of parentheses. You know, plus, you got negative 5x squared plus 2x squared. Okay, you see this is horizontal. I kind of like it vertically. I can see it better myself like this, but if you can see it better, like this, have at it. Whatever works for you. Okay, just make sure that you have the like terms underneath of each other or within the same parentheses if you're going to do it horizontally. Okay, subtract polynomials. So again, you want to look at both of these inside the parentheses and notice, are they in correct polynomial form? And they are. So the next thing we're going to do is we're going to make sure that we distribute this negative first. We love addition problems, so we want to turn this back into an addition problem. So by doing that, I want to distribute that negative. So when I distribute that negative, automatically turns into a plus sign, and now a negative of a negative 2x squared is a positive 2x squared. Negative of a 2x, because you're distributing to each piece, is a negative 2x, and negative of a negative 4 is plus 4. Okay, so I took this outside negative sign, distributed to each term inside the second polynomial. So from here, create our columns vertically if you want. 4x to the fourth, we don't have anything else that goes along with that. We don't have a degree of 3, so that's gone. We have a 2x squared on this one. We have a minus 2x, and then we have a 5 up top and a 4 on the bottom. So now combine these together. 4x to the fourth plus 2x squared minus 2x plus 9. And check the rules of polynomials again from left to right is in correct order. Decreasing exponents from left to right, or the degree is decreasing from left to right. My leading coefficient is 4. My degree is 4 as well. Okay, my constant term is 9. Okay, so make sure you can identify all those points. Make sure you put that on your note card. Okay, so go back. I'm only giving you 2 examples, one of a addition problem. Okay, make sure you have the like terms underneath each other, and then one of a subtraction problem. And it's very important. We love addition, so we want to make sure we distribute that negative first to turn it back into an addition problem. Okay, here's your homework. Okay, problem number 1, problem number 2. And we'll talk in class more about definition of polynomials and monomials. Okay, so if you have any questions, email me. I hope you have a wonderful day, and we'll talk soon. Take care.